We're going to start lesson 2.7 from the lesson book. This section covers solving equations, but a special type of equation called proportions, ratios and proportions. And we'll introduce the idea using population density, an idea related to cities and how many people live in a city per an area, what we call the square area. And so let's take a look at the definition of population density. As you can see, here's the definition here, and here's the equation we end up using, just taking the number of people in an area divided by the total area, and that's population density. For example, Seattle, population density, or a square has 600,000 people and 142 square miles. What is the population density? And so you just divide that, and so this number that you end up getting here tells you how many people live within a square mile. And again, imagine 1 mile long and form a square, and what we're looking at there would be a square mile. So you can imagine how many people live within a small area. And of course, the more you live in a city, the more dense it is. And so let's look at an example here of kind of looking at density within like a smaller space, like a stage. And so here's an example here looking at a 20 by 20 foot stage. There's 100 people. That's a total of 400 square feet because you do 20 times 20 since you have this square area. And so what would the population density be for that space? You would say 100 people per 400 square feet. But that gets simplified to one person per 4 square feet. But many times, not many times, population density is often expressed as the number of people per unit. So that's an important distinction, per square unit. So I want the answer to be 1. So if I have 1 person per 4 square feet, technically we would say that's 0.25 people per 1 square feet. So we can imagine how many people within 1 square feet. Since most people have a sense of 1 square foot. It's kind of like the tile size on the floor of a classroom. And so looking at another situation here, how about a 10 by 10 with 25 people on it? 25 people per 100 square feet. Notice it simplifies into the same population density. The densities are the same in those two situations. And so if you think about that 20 by 20 square foot with 100 people on there, and they start to move together, how does this affect the population density of the stage? Technically it doesn't, because the calculation would be the same, 100 people per 400 square feet. But in reality, as you think, that's the overall average. In reality, as people cluster up, the population density where people are clustered will increase per square foot. So technically overall it would be the same, but you can already imagine if people cluster up together, you end up with a different population density if you look at small spaces. So that's the introduction to population density, and then we'll look at this with respect to proportions.